guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Chemistry 11 content. What we're covering today is going to be naming compounds, and we're going to look at a couple of the different methods when you're naming the compounds. Alright, so with that, let's get started. Okay, so I'm going to write down the example on the board here. Okay, and we're going to try and solve it together. And so let's start off here. Okay, so it's basically writing the names of these binary ionic compounds, okay, using the IUPAC system of chemical nomenclature. Okay, so one more time, let's do like a quick review here. If I have NaCl, okay, I know that this is an ionic compound because it consists of a metal and a non-metal. Okay, when I'm naming this, I'm just going to name the metal first. So I have sodium. Okay, for the non-metal, it's chlorine, and make sure you're adding IDE at the end. Okay, so it becomes sodium chloride. Okay, so just like this. All right, let's try one more here. Okay, so say I have, okay, I'm gonna give you the compound. So say it's CaO. All right, again, this is ionic here. Okay, Ca is calcium, and if you're not sure, make sure you are checking the periodic table. And the O is oxygen. I'm going to add IDE, and this becomes calcium oxide. All right, does everyone see that? Okay. All right, and let's go to ones where you do have some of these transition metals, okay, because this is quite important. I'm just going to take this off. Okay, remember transition metals have more than one charge when you're looking in the periodic table. And the ones that we come and encounter or we're encountered with on a daily basis include something like maybe iron, copper. Okay, so let's try one where you have that. Okay, so say I have, let's try naming the compounds here. Okay, so let me write the formula on the board. So say it's Ni2O3. Okay, this is a binary ionic compound. Okay, so if you do check nickel in the periodic table, you'll notice that it has two charges here. Okay, and in this case, if you're looking at like what the charge is, okay, for nickel, okay, it's coming from the opposite side. Instead of using the crossover method, what we're using here is the reverse crossover method. Okay, make sure you're using a periodic table where the charges are given. So if I look in the periodic table at the back of the textbook here, nickel has two charges. It is 2+ and it is 3+. Okay, so if you're looking in this case here, this 3 is actually coming from the nickel. So remember, when we are writing the compounds, okay, we're using the crossover method. So in this case, I know that nickel has a charge of 3. Okay, so I'm going to write nickel 3 and then oxide. Okay, so a lot of students will just write nickel oxide. Again, the teacher will take off half a mark on a quiz or test. Okay, because nickel has two charges here. Okay, I'm going to pick another good example from here. So let's try this. So I have FeCl2. Okay, Fe is iron. Iron has a charge of 2+ and 3+. So I'm going to put iron, and this 2 is coming from the iron. Okay, and remember, chlorine just has a charge of 1-. Okay, so I'll put the 1- here. That 1- actually goes between the Fe and the Cl. Okay, but in this case, we're only concerned about iron. So in brackets, you have to actually use the Roman numerals. Okay, this is the IUPAC name and how you name the compounds. Okay, so it's going to be iron 2 and then chloride. Does everyone see that? Okay, so just like this. Are there any questions so far? Okay, it looks good. All right, so I'm going to just take this off. And let's try just a couple more examples. Okay, and then we will move on, okay, to the next naming system. Okay, so let's try this one. So I want to try one that's different. So let's try this. So PbCl4. Okay, you're checking the periodic table. Pb is lead. Lead has a charge of 2+ and 4+. In this case, this 4 is coming from the lead. So when you write it in words, lead 4, and 4 is basically like IV in Roman numerals. And there's chlorine, so I'm going to write chloride. Okay, so the name of this compound is going to be lead 4 chloride. And that's actually how you say it as well in terms of its name. Okay, and the reason you have different charges is because when you're using these actual elements in the laboratory, okay, it's going to give you a different compound that is actually formed. All right? Okay, and let's try one last one here. Let's just write it here. Okay, so I have Cu and I2. Okay? This is a solid, okay? It's an ionic compound. So Cu is copper. It has a charge of 1 plus and 2 plus. This 2 is coming from the copper. So I'm going to write copper. And then 2. So you're just going to draw like 2 lines like this. Okay, and then I is iodine. So I'm going to put iodide. Does everyone see that? Okay, good. So this looks good. Okay, this is in terms of just the IUPAC name, okay, as well. The second method for naming compounds is using the classical name, okay? So I'm going to take this off. Okay, and in the classical name, I can only apply this, okay, when the transition metal has only 2 charges, okay? So let's put down classical method. Okay, so what we're going to do here, okay, is I'm going to pick an example, okay, for one of these compounds. Okay, so let's try this one. So say I have FeCl3, okay. So I know iron only has 2 charges here, okay. So when you're doing iron in terms of its lower charge, so I'm going to write it on the side here. So it's Fe2 plus. You actually just name it as ferrous, okay? And so you use the OUS to indicate the lower charge, okay, for this transition metal. And you're using ferric if it's the higher charge on the metal, okay? So I'm going to put ferric. And it's the IC ending here, okay? That indicates the larger charge, okay, for the metal. So say I'm looking at this example. I see that this 3 is coming from the iron, okay? And because the charge on iron is 3 plus, I just need to write ferric. So I'm going to write ferric chloride. Okay, and so in this case, I don't need to indicate what the charge is in terms of the Roman numerals and brackets. As soon as I write ferric, everyone knows that the charge on the iron is 3 plus. All right? Okay, so let's try one more example here. Okay, so let's try copper. Copper is used quite often in the laboratory. So I'll just take this off. Okay, and some of these transition metals, you should memorize, okay, the classical name for it, okay? So I'm going to put an example. Okay, so let's do copper. And we'll do Cl2, okay? Just to keep it simple, so everyone can see how you're naming this method, or using this method. Okay, now copper has a charge of 1 plus and 2 plus, okay? So say the charge on the copper is 1 plus. How you would name it is cuprous, again with the OUS ending indicating the smaller charge. And if the charge on copper is 2 plus, it would be cupric. Okay, and this is with the IC ending. Alright, so now say I'm looking at this example, I want to name my compound. This 2 is coming from the copper, so I know the charge on the copper here is 2 plus. This is going to be cupric. And Cl, which is chlorine, so cupric chloride. Okay, everyone sees how to use this method? Okay, another common example, okay, of a transition metal, okay, that's used naming this method is mercury, okay? So let's try one example for mercury here. We'll just take this off for copper. Okay, and you notice the transition metals we're going through are the ones that you will most likely encounter, okay, whether or not it's in the laboratory, okay, or in like a regular setting as well. Okay, so we were doing, let's try HgO, okay. I remember oxygen makes a lot of different compounds, okay, with transition metals as well as just regular metals. All right, and let's put mercury. Mercury has a charge of 1 plus and 2 plus. If the charge is 1 plus here, okay, it's going to be mercurous, okay. Make sure you're putting the OUS, okay, as the ending here. And if the mercury has a charge of 2 plus, it's going to be mercuric. Okay, so like this. All right. So those are the two charges for Mercury if you're looking at this example. Okay, so if you notice here, sorry, so I'm just going to put 2 here. Okay, just because I know the oxygen has a charge of 2 minus, okay, that's why it's going in between the mercury and the oxygen. So if there's nothing here, oh, actually, like we could actually just leave it as well. I'll show you both of the examples here. This is a good example. So even if you have HGO here, okay, I know that the charge of oxygen is 2 minus, okay? The charge on the mercury has to be 2 plus. That's why both of these numbers are canceling out, right? And there are no subscripts that are found on the bottom. Okay, so this is a really good example. So the charge on the mercury in this example is going to be 2 plus, okay? And therefore, we're going to name it as mercuric oxide. Okay, so it looks like this. Okay, and I just wanted to show you that other example. So say the charge, so now put Hg2O, okay? Now if you look at this, okay, I can see, so I'll make it bigger. I can see the 2 is actually coming from the 2 minus, and that's the charge on the oxygen here. Okay, if there's nothing beside the oxygen, it's not like a 0. So just like in math, it's actually a 1. Okay, and then we'll take out this charge. Okay, so there's actually a 1 beside the oxygen. This 1 is coming from the mercury. Okay, so I know that the charge on mercury is 1 plus, which is a lower charge. So I'm going to put mercurous oxide. Okay, does everyone see the difference here? Okay, so I do have to make sure that I'm looking at the subscripts in order to do the reverse crossover method, and that way I can kind of tell what the charge is on the transition metal. Alright, so that looks good, and that brings this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I'll see everyone in the next video. Thanks, bye.